Here we're going to go over solutions to exam 1. Number 1, find each limit, show all work. You may not use L'Hopital's rule, whatever that is. First, limit as x approaches 5, x squared plus 2x minus 35, all over x squared minus 25. Well, you try substituting, you get 0 over 0. But fortunately, it does factor on the top and the bottom. The bottom is x minus 5 and x plus 5. The top is what? X minus 5 and x plus 7. Those cancel, then you can substitute. You get 12 over 10, which reduces to 6/5. And that's part A. Part B, limit as x approaches -3 from the left of what? X times x minus 4 squared times x plus 2 cubed, all over x plus 3 cubed times x plus 4 to the 7. Well, you do a substitution here, you get a number over 0. And when that happens on the left or right of -3, we know it'll be an infinity. We have to figure out the sign. And we'll do that by considering numbers to the left of -3. Put them in the first thing on top, you get a negative. Put them in the second thing on top, and square it, you get a positive. Put them in the third thing on top, you get a negative cubed, which is a negative. On the bottom, you get a negative cubed again, which is negative. And you get a positive to the 7th. 3 negatives make that a negative infinity. Next, limit as x goes to -infinity. 1 plus e to the x. There are 2 ways you can do this. I'll show both ways. First, you could split the limit as x goes to infinity of 1, which is 1, plus limit as x goes to -infinity of e to the x, which I'm going to do by converting it to a limit as x goes to positive infinity of e to the negative x, which is 1 over e to the x. As x goes to infinity, e to the x goes to infinity. 1 over something which goes to infinity goes to 0. I was going to circle 1 plus 0 with a square. So you get 1 plus 0, which equals 1. Now, so that's one way you could do it. Another way is with graph transformations, because we know the graph of e to the x looks like this, with horizontal asymptote at 0. So in particular, limit as x goes to -infinity of e to the x is 0. But that's not this function. This function is that lifted up 1 unit, which will look like that, lifted up 1 unit, with horizontal asymptote now of y equals 1. And as x goes to -infinity there, that curve approaches 1. So either way you want to conclude is fine with me. I actually like the first argument a little more, but the second one works fine. 2, without using the coefficient theorem, which I threw in quotes, find this limit. So using the coefficient theorem, since degree on top is 3, degree on bottom is 4, and we're going to infinity, we would expect the answer to be 0, but we have to show that if we want credit. Divide everything by x to the 4th, because that's the largest exponent on the bottom. And what do we get? Limit as x goes to infinity of 4 over x minus 3 over x cubed plus 6 over x to the 4, all over 5 over x to the 4 minus 9 over x squared minus 1. And what do we get? We get 0 minus 0 plus 0 over 0 minus 0 minus 1, which is 0 over -1, a fraction, which reduces to 0. Number 3. Come on, let's go to the next page. Okay, number 3. 3. Use the definition of the derivative on this function. 3x squared minus 5x. Well, f prime x is limit as h approaches 0 f of x plus h, so 3x plus h squared minus 5x plus h minus f of x minus 3x squared minus 5x all over h. And what do we get? Limit as h approaches 0. So we have 3x squared plus 6xh plus 3h squared minus 5x minus 5h minus 3x squared plus 5x all over h. So what do we have? Those two cancel. Those two cancel. And we're left with 6xh plus 6xh plus 3h squared minus 5h all over h. I guess I'll write that. All over h. You can't do a substitution, but you can divide everything by h. You get 6x plus 3h minus 5. And as h approaches 0, that goes to 6x plus 0 minus 5. So that was part A. And that is the answer we should have gotten based on what was written in part A, but also based on some power rules. Find an equation for the line tangent to the function at x equals -1. So -1, substitute that into the function, you get what? 3 plus 5. -1, substitute that into the derivative. What do you get? -11. So what do we have? Y minus 8 equals -11, x plus 1. Number 4. Should fit down here. Using one of the two discussed approximation methods, approximate the area between the function and the x-axis interval 1 to 2. There's 1. There's 2. Using two rectangles, so all we need is the point between them, 1.5. So you need only one of the approximations. I will show both of the approximations because some of you might have done one, some of you might have done the other. If I were taking the test as a student, not as a test giver, I would do the right-hand approximation because f of 2 is 0. So what do we have for the left-hand approximation? F of 1 is 7. Is that right? F of 1 is 7, yeah. Plus f of 3/2, which is what? 8 minus 3/2 cubed, 27/8. So what do we get? A half of 15 minus 27/8, which is what is that? 93/16. Yeah. Which does reproduce. So the inside there, 15 times 8 is 120. 120 minus 27, 93. And 8 times 2 is 16. You could have done that. You could have also done the right-hand approximation. I'm going to squeeze that on this page because it'll fit since the 1 is 0. The left-hand approximation, remember, uses those points. The right-hand approximation uses those points. So here, R2 is a half times f of 3/2 plus f of 2, which is what? A half. F of 3/2 is 8 minus 27/8. F of 2 is 0. So that's that 37. 64 minus 27 is, yes, 37. 37/16. And this was part A. And remember, you did have to do only one of those two. Now, part B, does your approximation give an over and under approximation? If you did both, you would notice because it's a positive function, the left-hand approximation gives an over approximation since it's larger than the right-hand approximation. That's one way you could conclude it. Another way you conclude it is by, oh, I need a new page. Another way you conclude it is by doing the actual area using a limit. I would not recommend that. Another way you can conclude it is by drawing the function. We can draw this function because, let's go to the top of this page. Because we know what x cubed looks like. y equals x cubed. So we know what negative x cubed looks like. Flip that over the x-axis, or the y-axis, since it's not a function. What does that mean? So here's y equals negative x cubed. And then with that 8 units, puts us up here. And that's what, 0, 8. Over here, that happens to be 2, 0. It doesn't matter, though. If you draw the rectangles, what do we get? Well, the left-hand rectangles would look like that. This is y equals 8 minus x cubed. So the left gives an over approximation, and the right will give an under approximation. I'll show what that looks like over here. This function looks like that, and that. The right gives an over approximation or an under approximation. Why is that? Well, the right-hand approximation looks like that. Maybe I'll fill in the squares, rectangles, whatever. And the right-hand approximation has that rectangle with area 0 and that other rectangle. So that's one way. That's how I would have concluded it with a drawing. Or you could have said the one is larger than the other, and it's a positive function, so it's so the larger one is an over approximation. Here, f prime of x for x to the 7th minus 3x cubed minus whatever. Derivative of x to the 7th using power rule, 7x to the 6th. Negative 3x cubed, derivative of that, negative 9x squared using power rule on the constant rule. Derivative of x, coefficient is just 1. Next, we have negative 5 times negative 6, x to the negative 7th. And the derivative of e is 0 because e is constant. 6. Consider graph A. Okay. Great. What does the quantity represent? Well, this is the slope of the line. That's not how you spell line. On graph A, the reason I intentionally labeled that line is so you would refer to it as line in part A. When you look at that graph A, I mean, when I look at that, I think, why does that say line? That's obviously a line. I put it there to help with 6A, actually. Part B, is there a value x in the interval a to b with f prime of x equal to the slope of the line? Why? Well, the answer is yes. There's 1. And why is that? Well, we have this curve with that line, f prime of, well, the right-hand side of this equation, the f of b minus f of a all over b minus a, that's the slope of the line. The right-hand or the left-hand side of the equation, is there a value x where f prime of x? Is there a value x where the slope of the tangent line equals the slope of the line? Is there a value x where the slope of the tangent line, the line tangent to this curve, that's not what this curve looks like. That better not be what it looks like. Oh, there are 2. Okay, there are 2. If you said 1, you get full credit. Because I wasn't actually looking down there. There's actually a second underneath it. More on that later. Is there a value? Oops. If you said 1, that's full credit. All I wanted to see was 1. Well, if you said 1 and justified it, it's full credit. If you said 2 and justified it, full credit. Is there a value x where the slope of the tangent line equals the slope of the line? Is there? Slope of 2 lines being the same means, is there, or 2 lines having the same, 2 lines having the same slope means the lines are parallel. Two lines having the same slope are parallel. So is there a tangent line that's parallel to line? Yes, right there. There's one. So there's a value x. In this curve, there happens to be another down here. Is there a value x where the slope of the tangent line equals the slope of the line? Well, right here is one. Right here is another. So right here where we have the interpretation of the derivative as the slope of the tangent line, but we combine that with two lines having the same slope being parallel. You know, I've explained that each of the last several semesters. I haven't had as much trouble forming words as I had this time. Two lines with the same slope are parallel. Anyone in a linguist class might be able to explain why I was having trouble with that. There are a lot of S's and L's in that sentence. But remember, the derivative at a point gives you the slope of the tangent line. So here we're looking for where the slope of the tangent line equals the slope of line. Number 7. Prove each statement by choosing 2 points on an appropriate line. A, the slope of a horizontal line is 0. So I expect you to do something like this, where you took a horizontal line, you took 2 points, say 1, 4, and 2, 4, and showed that the slope is what? 4 minus 4 over 2 minus 1, 0 over 1 is 0. I expected something like that. And similarly for part B, where you pick 2 distinct points on the line. But I'll prove it in general. You know, it's not a proof class, so you know, I said on an appropriate line, meaning you could just pick, you know, in this case, y equals 4. But in general, what would this look like? Well, pick 2 points. Well, 1 up B and 2 up B. I want to use B. Let's just use Y. No, B is better. We already have Y for the y-axis. Yeah, okay. So 1B and 2B for the line y equals B. And what do I do? There. And here, the slope is what? B minus B over 2 minus 1, or 0 over 1 equals 0. And similarly for a vertical line, pick 2 points. So we'll choose the line x equals A. So we have what? A, 1. I considered saying in this recording the slogan for the A1 steak sauce after saying A1, but I held myself back because I don't like A1 steak sauce. I like steak plain. Well, plain meaning with salt and pepper. So here we have the points on the line x equals A, A1 and A2. So the slope is what? 2 minus 1 over A minus A, which is 1 over 0, which is undefined. So again, I didn't expect you to prove those in general, but you know, if you wanted to see a general proof, that's what it would look like. Next, let f of x, this is 8, let f of x equal x to the 4 plus x to the 3 minus 3x to the 2 minus x plus 1. Part A, is f of x continuous? Yes. Why is it continuous? I didn't ask why, but it's continuous because because f of x is a polynomial. Polynomials are continuous everywhere. B, find f of 0, f of 1, and f of 3. Without using a calculator should be assumed, but you know, just to hammer it in there, you shouldn't use a calculator. F of 0, 0 plus 0 minus 0 minus 0 plus 1 is 1. F of 1, 1 plus 1 minus 3 minus 1 plus 1, what's that? 3 minus 4. F of 3 is 81 plus 27 minus 27, minus 3 plus 1. 27's cancel, equals 79. Great. Part C, how many x values are there in the interval 0 to 3 with f of x equals 0 and why? This is asking about the interval 0 to 3. Well, I asked part B and part A actually for a reason. Part A tells us that we have this point, 0, 1. Part B tells us we have this point, 0, negative 1. Part C says we have this point, 379. This is a continuous function. So it's going to have to connect all these points somehow. Somehow. What is it? This is 3. It's continuous. So we'll say f may look like this. So how many x values are there with f of x equals 0 and why? Well, according to this drawing here, well, what's a value x where f of x equals 0? A value x where f of x equals 0 is a value where y equals 0, where the height of the function is 0, where the function intersects the x-axis. So if your function looked like this, there are 2 such x values. But we don't know necessarily that the function looks like this. I'll squeeze this in the bottom of this page. We do know that it goes through these points. What if it looks like this? I mean, it doesn't, but based on what we know, it could look like this. And in this case, it has 1, 2, 3, 4, 5, 6 such x values. So there could be 2, there could be 6, there could be any number, but it must be at least 2. So the correct answer here, the fully correct answer is at least 2, based on what we know. You could say between 2 and 4 with the degree of the polynomial. We didn't cover the degree of the polynomial, so no, I'm not going to say anything more about that. But based on what we know, using calculus, there are at least 2. So I'll stop that there. I could say a little more about that. So I hope this helped. Definitely, if you got some of these questions wrong, definitely look at these explanations and try to make them natural in your mind. And some of it we won't see again until the final, but there is some of it that will definitely show up on the final. So I hope this helped.